Hello everyone. So today's topic is conic sections. Conic section. So in this we will study about circles, ellipse, parabola, and hyperbola. And these curves are obtained when a plane is intersected with a double napped cone. With double napped cone. So what is double napped cone? So if we have a inverted cone like this, and this is second cone, so this is known as nap of the first cone, and this is nap of the second cone. So we call this double nap cone. Where the point this point is known as vertex. So what is a conic section? What is conic section? If we take if we take the intersection of a plane with a double napped cone, the section so obtained is called conic section. The section so obtained is called conic section. So what kind of conic section? What kind of conic section? So this depends on the position of intersecting plane with respect to the cone. So this depends on the position of intersecting plane with respect to cone. With respect to cone. And the angle made by and the angle made by it with the vertical axis of the cone. With the vertical axis of the cone. So if let's say we have a double napped cone. So this is inverted cone, and we have second cone below it, which is exactly same like the above top cone. So this is double nap cone, where this line is known as axis of the cone. This line is axis of cone, axis of cone, and this is vertex, and this is nappy. So this is an angle of cone. Alpha is equal to semi cone angle, semi cone angle, and we have a plane which has an angle with the axis of the cone, which is beta. So this is a plane surface which is intersecting the cone at an angle beta with the vertical axis of the cone. So alpha is a semi cone angle, and beta is the angle made by the plane with the vertical axis of the cone. Beta is the angle made by the plane with the vertical axis of the cone. And L is the axis of cone. This is L. L is a axis of cone, and where V is vertex. So this is a notation of a double nap cone. So when the plane cuts nappy, then we get three different types of curves. When the plane cuts nappy, then we get three different types of curves. Three different types of curves. Depending on the value of beta, depending on the value of the angle which the plane makes with the vertical axis of the cone, angle beta which the plane makes with the vertical axis of the cone. So first is when beta is 90, beta is 90 degree, then we get section as a circle. Section is circle. That is, if we have a double nap cone and this is a vertical axis and this is base, so this is like this, and so this is a double nap cone, and this is alpha, and we have beta is equal to 90 degree. So this is a plane surface. So we get beta is equal to 90 degree. So section will be circular section at the intersecting point. So this is circular in shape when beta is 90 degree. Second is when beta is greater than alpha and less than 90. When beta is greater than alpha and less than 90 degree. So the section is ellipse. Section is ellipse. that is so this is vertical axis, and this is alpha, and this is beta. So here beta is greater than alpha and less than 90 degree. So we get a ellipse as a conic section. So this part is ellipse AB. So next is when beta is equal to alpha. When beta equal to alpha, so we get parabola. So this is this is vertical axis of the cone, and when beta is alpha, so this is alpha, and a plane will the angle will be equal to alpha, so it will cut the above cone at an angle alpha. So this is beta, where beta is equal to alpha. So this is a curve ABC. Curve ABC is a parabola. So this is a plane at an angle beta, which makes the section parabola when beta is equal to alpha. And last is when beta is greater than 0 and less than alpha, so we get hyperbola. And hyperbola always occurs in pair. Hyperbola always occur in pair. So this is one cone, so we have beta is less than alpha, so this is vertical axis. So the plane will cut the cone, the upper cone and lower cone, so we get two hyperbolas. So it will be A, and this is B, and this is B dash, and this is A dash. So this is when beta is less than alpha. So this is hyperbola. So one hyperbola in the upper cone and second hyperbola in the lower cone. So this is like this. So next is what are degenerated conic section? What are degenerated conic section? So when the plane cuts at the vertex of a cone, then we have three curves. When the plane cuts at the vertex of the cone, then we have three curves that is when alpha is less than when beta is greater than alpha and less than 90 degree. So the section is point. That is so if this is a cone and this is a upper cone and this is a lower cone. So if a plane cuts at this point at an angle beta equal to 90 degree, so this angle is 90 degree and this is a vertical axis. So we get a point as a section where beta is 90 degree. So section is point. Second is when beta is equal to alpha, then we get a straight line. That is, if this is a cone and this is the vertical axis of the cone and beta is equal to alpha, this is alpha, so plane will cut along this slant height of the cone. So this is point B and this is point A. So it will cut both the cones and the section will be straight line. Where beta is equal to alpha. Third is when beta is greater than 0 and less than alpha. So the section is a pair of intersecting line. Section is pair of intersecting line. That is, if this is a cone and this is a double nap cone, so if beta is less than alpha, so this is how the plane will cut when beta is less than alpha. So this is beta, which is less than alpha. So we get two intersecting lines. So this is point A and this is point B and this is point A dash. So we get two intersecting lines. So this is B dash, where AB is a one line and A dash B dash is another line. So AB will intersect A dash B dash when beta is less than alpha. Next is first is circle. So when we get circle when beta is equal to 90 degree. So a circle is a set of all points in a plane. A circle is a set of all points. Circle is a set of all points in a plane that are equidistant from a fixed point. in the plane. So where fixed point is known as is called as center of circle. Where fixed point is called the center of circle. And the distance from the center to the point on the circle is called radius of the circle. And the distance from the center to a point on the circle is called the radius of a circle. So let us make a circle. So this is a circle and this is y-axis and x-axis, where point C is, let this coordinates of C be h and k, and there is a point P, any point P and P, such that CP is equal to radius of the circle R. So if C is a center and P is any point, on circle, then the distance between C and P is equal to radius of a circle. Radius of a circle is equal to R. So by distance formula, Cp is equal to, in bracket, x minus h whole square plus y minus k whole square. So we get x minus h plus y minus k is equal to r square. So this is the required equation of a circle, where h comma k is the center of a circle and r is the radius. And radius r. So next is parabola. So a parabola is a set of all points that are equidistant from a fixed line. And fixed point, where fixed point is not on the line. Fixed point is not on the curve. And fixed line is called directrix of parabola. A directrix of a parabola. And fixed point is known as focus. Fixed point is known as focus of a parabola. So suppose we have axis of a parabola. This is axis, and this is parabola, and this is focus, fixed point, and this is directrix. And let this be any point P over the curve x comma y. So what is axis? So this is directrix. So what is axis? So align through the focus and perpendicular to the directrix is called axis of a parabola. Align through the focus and perpendicular to the directrix is called parabola. That is, if this is the axis which is through the point fixed point focus, so this is axis through focus, and which is perpendicular to the directrix, so this is a directrix. Next is, what is vertex? So point of intersection of a parabola with the axis is called vertex of a parabola. A point of intersection vertex of parabola. That is, if this is a axis and this is a parabola, then the parabola will intersect the axis at point V. So this point is vertex. So next is standard equation of a parabola. So what is a standard equation? So here standard means the vertex is at origin. So standard means vertex is at origin. So let's construct the parabola. So let f be any point at some point a comma 0, a comma 0. So f is a focus. So this is axis and this is focus, a comma 0. where this is y-axis. Second is, let the directrix be at minus a comma 0. Let the directrix be at minus a comma 0, or equation of directrix is x plus a equal to 0. So this is y-axis, and this is focus f point, that is a comma 0, and we have a directrix at minus a comma 0, minus a comma 0. So directrix is represented by a vertical line parallel to y-axis. This is a directrix at minus a equal to 0. And this is a focus. Next is, we have a vertex at origin. So vertex at origin. So vertex at origin. So vertex mean that the parabola intersect the axis at 0 comma 0. So this is a parabola which intersect axis at origin. Now consider any point P where x comma y, and join PF. Next, drop perpendicular from point P on directrix. So this is a perpendicular from point P. So this is a perpendicular from point P to the directrix. And let this point be B, and its coordinate will be minus a comma y. So we have PF and PB, where coordinates of B are minus a comma y, and coordinates of P are x comma y, and coordinates of F are a comma 0. Now from a definition of parabola, from a definition of parabola, the perpendicular distance PB is equal to the distance PF. So by distance formula, root of y minus y whole square plus x plus a whole square, root of x minus a whole square plus y minus 0 whole square. So this will become 0, and x plus a is equal to x minus a whole square plus y square. This will become square, so x square plus 2ax is equal to x square plus a square minus 2ax plus y square. So we get y square is equal to 4ax. So this is the equation of parabola where a is greater than 0. So there are four types of parabola. There are four types of parabola. That is, first is x square is equal to 4ay. So this is a parabola, and this is a vertex, and this is a directrix. Also, this is y square is equal to 4ax, where this is vertex and we have focus at a comma 0 and directrix at minus a comma 0. Second is y square minus 4ax. Y square is equal to minus 4ax. So this will open leftwards. Directrix will be at a comma 0 and focus will be at minus a comma 0. This is directrix. This is vertex. Next is x square is equal to 4ay. So this is a parabola which open upwards. Where origin is a vertex and directrix is at 0 comma minus a and focus at 0 comma a. This is directrix and this is vertex. This is focus. Last is x square is equal to minus 4ay. So this parabola will open downwards. Where origin is vertex and directrix is at 0 comma a and focus will be at 0 comma minus a. This is focus, this is directrix. So there are some important observations. Some important observations. That is, first, parabola is symmetric with respect to axis of parabola. Second is, when the axis of symmetry parabola opens right or left. When the axis of symmetry is x-axis, then parabola opens right or left. And third, when the axis of symmetry is along y-axis. Then the parabola opens upward or downward. So next is, what is a latest rectum? What is a latest rectum? So latest rectum of a parabola is a line segment perpendicular to the axis of parabola through the focus and whose end point lie on the parabola. Latest rectum of a parabola is a line segment perpendicular to the axis of parabola through the focus and whose end points lie on a parabola. That is, if this is axis and this is parabola at origin, this is directrix, and this is focus. So what is latest rectum? So it is a line segment perpendicular to the axis through focus. So perpendicular to the axis through focus, and whose endpoints lie on parabola. So A and B are endpoints. So AB is a latest rectum. AB is a latest rectum where coordinates, and if we drop a perpendicular from A to directrix, let this point be C. So then we can say AC is equal to AF from a definition of parabola. So coordinates of C are minus A comma Y, and coordinates of A are A comma Y, and coordinates of F is A comma 0. So from parabola definition, AC is equal to AF, that is perpendicular distance AC is equal to AF. So AC is, by distance formula, Y minus Y equal to 0, my plus A equal to square is equal to A minus A 0 plus Y minus 0 whole square. So this will cancel out, this will cancel out. So we have 2A whole square is equal to Y square. So Y is equal to 2A. But latest rectum is equal to AB, which is equal to AF is equal to 2A. But latest rectum is equal to AB, which is equal to AF plus BF, where AF is equal to BF. Therefore, AB is equal to 2 times 2A, that is 4A. So latest rectum is equal to 4A. Next is, so this was about parabola. Next is ellipse. Ellipse is ellipse is a set of all points in a plane. An ellipse is the set of all points in a plane that is the sum of whose distance from the two fixed point is constant. So if this is a focus 1 and this is focus 2 and this is a parabola, this is a ellipse, and if we consider a point P, any point P on ellipse, then Pf1 plus Pf2 is equal to constant. Again, if we consider any point Q on the ellipse, then we can say Qf1 plus Qf2 is equal to constant. So likewise, we can take any number of points. So where F1 and F2 are foci of ellipse. So let the distance between two foci be 2c. Let the distance between two foci be 2c. That is, this is F1 and this is F2. So this distance is 2c. And the constant mentioned in the definition of ellipse is always greater than the distance between two fixed points. That is, the constant in the definition of ellipse, that is, this constant is always greater than the distance between two fixed points. That is 2c. So if p, q are any points, any number of points, then pf1 plus pf2 is equal to qf1 plus qf2 is equal to rf1 plus rf2, likewise is equal to constant, which is equal greater than 2c. So where c is a distance between f1 and f2. So what is the center of ellipse? So midpoint of a line segment joining the foci is called center of ellipse. Midpoint of the line segment joining two foci f1 and f2 is called center of ellipse. That is, if we have two foci f1 and f2, then the midpoint will be center of ellipse. Center of ellipse. That is, this distance will be c and this distance will be c because this is a midpoint. Next is, what is a major axis? What is a major axis? The line segment through the foci of the ellipse is called the major axis. Line segment through the foci of the ellipse is major axis. So f1 and f2 are two foci, and if we draw a line through f1 and f2 where endpoints are a and b, so therefore AB is a major axis. Second, what is a minor axis? So the line segment through the center and perpendicular to the major axis. So we know this how to locate center of ellipse. This is f1 foci 1 and this is foci 2. So midpoint of this distance between f1 and f2 will be center of ellipse. So the line segment through the center and perpendicular to the major axis. So this is A B, which is through f1 and f2 is a major axis. This is major axis, and a line segment through the center which is perpendicular to the major axis. So this line segment is perpendicular through the center of the ellipse which is at 90 degree, and we call this C and D. Endpoints are C and D, so this is a minor axis. So by definition, the line segment through the center of ellipse and perpendicular to the major axis is called minor axis. So next is, what are vertices? What are vertices? So the only the endpoints of the major axis are known as vertices. Only the endpoints of major axis are known as vertices. So if we have two foci f1 and f2 and major axis is through f1 and f2 where endpoints are A and B and AB is a major axis. So we can call A and B as vertices of a ellipse. Vertex A and this is vertex B. But if we suppose we have a minor axis at midpoint of at center of ellipse and the endpoints are C and D, this is minor axis. So C and D are not vertices. So the endpoints of the major axis can only be called vertices of an ellipse. So what is the length of major axis? Length of major axis equal to 2a, and length of minor axis is equal to 2b. That is, this is AB, this is foci f1 and f2, center midpoint of f1 and f2. So this distance is A and this is B. That is, we can call B as semi minor axis, and A as semi major axis. So next is relation between semi major axis, semi minor axis and the distance of the focus from the center of the ellipse. Relation between semi major axis, semi minor axis, and the distance of the focus from the center of the ellipse. So now consider an ellipse with major axis as AB, major axis as AB, and minor axis as CD. So CD. So if we join the curve, we get a ellipse where foci are f1 and f2. So we know this is a center O. So OB is equal to A, and OF2 is equal to C, and OC is equal to B. So from definition of an ellipse, from definition of an ellipse, the sum of distance of any point from f1 and f2 is always constant. So consider point C and point B. Consider point any point C and B on the ellipse. Therefore, for point C, we have CF1 plus CF2 is equal to, so this is O, this is O, and this is point C, this is F1, this is F2. So CF1 is equal to, by Pythagoras theorem, CF1 is equal to root of B square plus C square, which is similarly CF2 is equal to root of B square plus C square. So CF1 plus CF2 is equal to 2 times root of B square plus C square. So this is equation 1. Similarly for point B, so we can say BF2 plus BF1 is equal to, so BF2 is A minus C, this is A minus C, plus BF1 is A plus C, so this is A plus C, which is equal to 2A. So from definition of ellipse, CF1 plus CF2 is equal to BF1 plus BF2. So 2 times root of B square plus C square is equal to 2A. So we get root of B square plus C square is equal to A. So if we write in terms of C, which is a distance between F1 and F2, is equal to A square minus B square. So this is a relation between distance of the focus from the center of ellipse. So C is the distance of the focus, distance of the focus from the center of ellipse, and A is a semi major axis, and B is a semi minor axis. So there is a special case when two special cases. First is when c is equal to 0, then a square is equal to b square. Therefore, we get a circle. We get a circle when c is equal to 0. Next, when c is equal to a, that is b is equal to 0, then we get a straight line. So what is eccentricity of an ellipse? So eccentricity is of an ellipse is the ratio of distance from the center of the ellipse, distance from the center of the ellipse to the one of the foci, to the one of the foci, that is C, and to the distance from the center to the vertex of an ellipse. Of an ellipse. So by vertex means the endpoint of major axis, endpoint of major axis, that is A. So we get eccentricity is C by A, where C is a distance from center to foci, any one foci, one, or we can call F2, and A is a distance from center to any endpoint or vertex A or B, which is a semi of major axis. So we can write C in terms of E. C is equal to AE. Next is a standard equation of an ellipse. Standard equation of an ellipse. So by standard we mean the center will be at origin. Center will be at origin. So consider any point P, x comma y, and any endpoint or vertex of an ellipse. So this is a major axis A comma P, A and B, and we have a center at origin and two foci F1 and F2, which are equidistant from the center, and minor axis is perpendicular to the center of an ellipse. So this is minor axis, this point is C and this point is D. Now join the points and form a ellipse. So this is a ellipse with foci at C comma 0 and another foci at minus C comma 0, and point B is at A comma 0, and point A is at minus A comma 0, and point C is at 0 comma B, and D at 0 comma minus B. Now consider any point P on a ellipse. Consider any point on a ellipse That is, suppose this is a point P where its coordinates are x comma y. Now join P to PF1 and PF2. So PF1 and PF2. So now consider 2 points, 2 cases for point P and point B. So from definition of parabola, we have PF1 plus PF2 should be equal to BF1 plus BF2. So we have, so from definition of ellipse, we have PF1 plus PF2 is equal to BF1 plus BF2. So we know coordinates of point P are x comma y, and F1 is minus c comma 0, and F2 is c comma 0, and the coordinates of point B are a comma 0, and F1 is minus c comma 0, F2 is c comma 0. So now PF1 is equal to root of y square plus x plus c whole square, and PF2 is equal to x minus c whole square plus y square, and we have BF1 is equal to a plus c whole square, BF2 is equal to a minus c whole square. Now according to the equation, PF1 plus PF2 is equal to BF1 plus BF2. So y square plus x plus c whole square square root plus root of x minus c whole square plus y square is equal to a plus c plus a minus c. So which is 2a. So now take one term on the left, on the right side, y square, and take square on both sides. So we get 2a whole square plus x minus c whole square and plus y square minus 4a root of x minus c whole square plus y square. So y square will cancel out, and we get 4xc is equal to 4a square minus 4a root of x minus c whole square plus y square. So now again take 4a on the left hand side and 4a square minus 4xc. Divide by 4 on both sides. A x minus c plus y square is equal to a square minus xc. Square both sides of the equation. A square x minus c whole square plus y square is equal to a square minus xc whole square. We get x square plus c square minus 2xc plus y square is equal to a 4 plus x square c square minus 2cx a square. So a square x square plus a square c square minus 2cx a square plus a square y square is equal to a4 plus x square c square minus 2cx a square. So from the relation of c is square is equal to a square minus b square. So put this relation in this equation. So we get a square x square plus a square minus b square plus a square y square is equal to a 4 plus x square a square minus b square. So a square x square plus a4 minus a square b square plus a square y square is equal to a4 plus x square a square minus b square x square. So we get this, and this will cancel out. So we have b square x square plus a square y square is equal to a square b square. So divide both sides by a square b square. So a square b square, a square b square. So we get x square by a square plus y square by b square is equal to 1. Hence this is the equation of an ellipse. Equation of ellipse, where a is a semi-major axis and b is a semi-minor axis. Next is we have two equations, two cases. First is when ellipse lie between minus a and a. When ellipse lie between minus a and a, that is major axis is along x-axis. So the equation of ellipse will be x square plus y square by b square is equal to 1. And second is when ellipse lie between minus b and b. When ellipse lie between minus b and b, so major axis will be along y-axis and the coordinates are 0 comma b, 0 comma minus b. So the equation of ellipse will be x square plus b square plus y square by a square is equal to 1. So some important points related to ellipse are: first, ellipse is symmetric with respect to both the coordinate axes. Ellipse is symmetric with respect to both the coordinate axes. And second is foci is always on the major axis. Foci, that is f1 and f2, is always on the major axis. Always on major axis. So what is latus rectum in case of ellipse? So latus rectum of an ellipse is a line segment perpendicular to the major axis through any foci and whose endpoints lie on the ellipse. So latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci. Is major axis through any of the foci and whose endpoints lie on an ellipse, whose endpoint lie on a ellipse. That is, if this is a ellipse and this is foci 1 and foci 2, and if we draw any perpendicular line from this foci 90 degree, so it will intersect the ellipse at C comma D. And if we draw another perpendicular line through F2, let the intersection point be A and B. So both this A, B and CD are latest rectum. So coordinates of point F1 is minus C comma 0 and coordinates of F2 is C comma 0, and let the coordinate of point A be C comma L, where L is a semi length of latest rectum. So by the equation of ellipse, x square by a square plus y square by b square is equal to 1. At point A, x equal to c and y equal to L. So put this x and y in the ellipse equation. So we get c square by a square plus L square by b square equal to 1. Now put c equal to ae, where e is the eccentricity. Therefore a square e square by a square plus L square by b square equal to 1. So we get L square is equal to b square 1 minus e square. Again put e is equal to c by a, and if e square is equal to c square by a square, and we know c square is equal to a square minus b square, therefore e square is equal to a square minus b square by a square, which is equal to 1 minus b square by a square. So from here L square is equal to b square and 1 minus, and put e square as 1 minus b square, 1 minus b square by a square. So b square by a square. So we get L square is equal to b4 by a square. So L is equal to b square by a. So but latest rectum is equal to latest rectum. This is semi latest latest rectum, semi latest rectum. So latest rectum will be 2 times L, which is equal to 2b square by a. So LR. So latest rectum is 2b square by a for an ellipse. So this was about ellipse. So last curve of conic section is hyperbola. hyperbola. So hyperbola is a set of all points in a plane such that of whose the difference of whose distance from whose difference of whose distance from two fixed points in the plane is constant. So like in ellipse, we take a sum of distance from two fixed points. So here we take the difference of points from two fixed points. That is, if this is a axis of an hyperbola, so this is called as transverse axis, and this is a midpoint, and the axis through the midpoint, which is perpendicular to the transverse axis, is called as conjugate axis. So if this is a foci f1 and this is foci f2, and we have a hyperbola, because hyperbola occur in pair, so we have two hyperbolas. Now consider and the point of intersection of hyperbola on the transverse axis is a vertex. This is a vertex, this is also a vertex. Now consider any point P on any of the hyperbola and join P with f1 and f2. So from definition of hyperbola, P f1 minus P f2 equal to constant. So if we take any point on any hyperbola, like point Q, then Q f1 minus Q f2 equal to constant. Or any point R on the curve here, or S, T, U, V, likewise all the differences will be constant. So therefore we can write Pf1 minus Pf2 equal to Qf2 minus Qf1 equal to Rf1 minus Rf2 is equal to dash 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 equal to constant, where always this term is always greater than 0. So large distance minus a small distance, this is large distance and a small distance, and hyperbola always occur in pair. Hyperbola always occur in pair, as seen in the conic section. As seen in the conic section, when the plane cuts the double napped cone, when the plane cuts the double napped cone, we get two sections. In case of hyperbola, we get two sections in case of hyperbola. So this was about hyperbola and the definition of hyperbola. Next is eccentricity in case of hyperbola. Eccentricity in case of hyperbola. So just like an ellipse where eccentricity is less than 1 in ellipse because A is greater than C. But in hyperbola, E is equal to C by A, where C is greater than equal to A. Therefore, E is always greater than 1. Always greater than 1 in case of hyperbola. So consider a hyperbola with conjugate axis, and this is transverse axis. This is f1 and f2 and A comma B. So from definition of hyperbola, consider point A and point B. Therefore, AF2 minus AF1 should be equal to BF1 minus BF2. So we know point B is at distance A and point F is at distance C. So AF2 will be, so this will also be A. So AF2 will be A plus C and AF1 will be C minus A. C minus A, and BF1 is equal to A plus C minus BF2. BF2 BF2 is C minus A, equal to constant, that is AF2 minus AF1 is equal to 2A, and BF1 minus BF2 is equal to 2A is equal to constant. So in case of hyperbola, the value of constant is equal to 2A. In case of hyperbola, the difference such as PF1 minus PF2 is equal to QF1 minus QF2 dash 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 is equal to 2A. Next, relation between C and A and B. So from ellipse, we have the relation C square is equal to A square plus B square, or we can write B square is equal to C square minus A square. So this relation was for ellipse where C is less than equal to A. But for hyperbola, B square is equal to A square minus C square, because C is greater than equal to A. So next is standard equation of hyperbola. Standard equation of hyperbola. So standard means center will be at origin. Center will be at origin. And we know in case of hyperbola, B square is equal to A square minus C square, or c square is equal to a square minus b square. Now consider any point P on hyperbola. Consider any point P x comma y on hyperbola. That is, this is transverse axis, this is conjugate axis, and this is hyperbola. This is foci 1 and this is foci 2. So now consider any point P whose coordinates are x comma y. Join P to F1 and P to F2. So from definition of parabola, PF1 minus PF2 is equal to 2a, because the constant is equal to 2a in case of hyperbola. So coordinates of F1 are minus c comma 0 and F2 is c comma 0. So by distance formula, PF1 is equal to root of x plus c whole square plus y square minus root of x minus c whole square plus y square is equal to 2a. So now x square plus c square plus 2xc plus y square is equal to 4a square plus x square plus c square minus 2xc plus y square plus 4a root of x minus c whole square plus y square. So we get x square cancel, and 4xc is equal to 4a square plus 4a root of x minus c whole square plus y square. So cancel out 4 and take xc minus a square on the left side and take a square, and x square plus c square minus 2xc plus y square. So x square c square plus a4 minus 2a square xc is equal to x square plus c square minus 2xc plus y square. So from hyperbola we get c square is equal to a square plus b square. Therefore x square a square plus x square b square plus a4 minus 2a square x root of a square plus b square is equal to x square plus a square plus b square minus 2x root of a square plus b square plus y square. So from this x square, where a square plus b square minus 1 plus a4 minus 2a square plus 2x minus 2x root of a square plus b square is equal to y square. So after rearranging the terms, we get x square by a square minus y square by b square is equal to 1, and this is the equation of hyperbola. Next is a special case of hyperbola. Special case, that is when a is equal to b. So then it is a equilateral hyperbola. It is equilateral hyperbola. So last is latest rectum of hyperbola. Latest rectum of hyperbola. That is, if we consider a hyperbola and suppose we have this foci f1, and let this be a line which intersect the curve at A and B. So for and where coordinates of A is C comma L, where L is equal to semi latus rectum, and if this is f1 and this is f2, and join AF1 and AF2. So from definition of hyperbola, AF1 minus AF2 is equal to 2A. So this is minus C comma 0, this is C comma 0. So by distance formula, 2C square plus L square minus root of L square is equal to 2A. So 2A plus L whole square is equal to 4C square plus L square. So therefore we get 2A whole square plus L square plus 4AL is equal to 4C square plus L square, where C square is equal to A square plus B square in case of hyperbola. So we get 4A square plus L square plus 4AL plus 4A square plus 4B square plus L square. So this will cancel out. So we get L is equal to B square by A. So but this is a semi-latus rectum. Semi-latus rectum. So total latus rectum will be latus rectum will be total length of AB, that is 2L is equal to 2B square by A. So this is a latus rectum for hyperbola. Latus rectum for hyperbola. So this was about conic sections and various curves such as circles, parabola, hyperbola and ellipse. So thank you.